In chemistry, most reactions do not go 100% to completion. The reaction stops. What is meant by stops is that there's no longer a change in the amount of reactants and products. We call this state a state of equilibrium. And the extent of the reaction at equilibrium is measured by an equilibrium constant K. In the next set of problems, we're going to be looking at K and using K in our calculations. K is constructed by looking at the concentrations of reactants and products at equilibrium. Note here that the concentrations of the products at equilibrium is in the numerator and the reactants is in the denominator. These exponents are going to be obtained by looking at the coefficients of the reactants and products. For example, C, our product here, this exponent is going to come from the coefficient associated with product C. The exponent associated with product D is going to come from this coefficient. And by similar means, we're going to get our exponents for A and B in the reactants. This exponent comes from the coefficient with A. This exponent comes from the coefficient associated with B. In this initial set of problems, we're going to practice constructing equilibrium constant expressions associated with different chemical reactions. Being able to construct an expression for K is essential to solving these equilibrium problems. And here's our corresponding equilibrium constant expression. Note that the concentration of our products are in the numerator and our reactants are in the denominator. These exponents are obtained from the coefficients in the balanced chemical equation. Each chemical equation is going to have its own associated equilibrium constant expression for K. In the second problem, note that water is in the form of a liquid and does not appear in K. A reminder, pure liquids and pure solids are not included in K. So I'm going to write K for those reactions for which there's a pure liquid or pure solid. We just ignore that chemical. Okay, also note that I tend to use HO minus instead of OH minus for hydroxide ion. Doesn't matter, either one is fine. For this next chemical reaction, we have two solids. So when we write the equilibrium constant expression, we simply ignore those two chemicals because pure liquids, pure solids do not appear in K. So here's our equilibrium constant expression. Note that these exponents come from the coefficients in the balanced chemical equation. And for our last reaction, we again note that we have a solid. It's not going to appear in K. So the only entities that appear in our equilibrium constant expression are the products. And the exponents are obtained by from the coefficients in the balanced chemical equation.